Liking this video will help this channel to grow. So please go ahead and give this video a like. Well done for making it to the final section of this 4-part lesson. By now, you should have watched all 3 sections that were previously uploaded. Those sections were on solving linear equation with one unknown, with unknown on both sides, with brackets, and with fractions. As always, I encourage you to engage with the practice questions found in the description of each video. Now, let's have a look at what are exponents and roots. Exponent is another name for power or index. Now, these are seen as small numbers above a base number or a variable. So let's look at what that means. Now, what does the exponent tell us to do? It tells us how many times a number is multiplied by itself. So in context, for example, if I've got 8 to the power of 3, that 3 is called an exponent or power or index. Now, if we've got more than one, we call them indices. Now, 8 to the power of 3 here means 8 times 8 times 8. So that exponent tells us how many times we are to multiply 8 by itself. Equally, y to the power of 4 means y times y times y times y. So it could either be a number or it could be a variable. Important to note is that the exponent is seen as that small number on top of the variable or the number. So what are roots? Now, when we talk about a root of a number, the root of the number is the value that when multiplied by itself a certain number of times produces the original number. So in context, if I talk about the square root or the root of 49, the root of 49 is that number when I multiply it by itself a certain number of times gets me to 49. So this is the square root of 49 and the answer is 7. Since 7 multiplied by 7 gives us 49, we say that the root of 49 is 7. So it's actually the opposite of my exponent. If my exponent was a square, the opposite of that is square root. So I would say 7 squared equals 49, but the square root of 49 is equal to 7. And the cube root of 64 is 4. Since 4 times 4 times 4 is equal to 64. So 4 to the power of 3 is 64, but the cube root of 64 is 4. So they're actually opposite of each other. So another example is the 4th root of 16. Now, when there is no small number in the root, we have a square root. If we've got a cube root, a 4th root, a 5th root, a 6th root, there will be that small number inside of the root. As you can see here, there is 3 in the root, that's a cube root. There is the 4 in the root, so this is the 4th root of 16. This indicates a number that when multiplied by itself 4 times, the answer will be 16. So the 4th root of 16 is 2. Since 2 times 2 times 2 times 2, we do that 4 times, will give us 16. So what we're going to do in this lesson is to solve equations that involves roots and powers. Very important to note, the same principle we have discussed in the 3 sections we've done before still applies for solving equation. We still do the opposite of our operation, which means that it's important to note that the opposite of square is square root, the opposite of cube is cube root, and so on. Beautiful. So to solve equation with exponents and roots, we follow the steps below. Similarly to what we've discussed before, if there are brackets involved, we expand those brackets. We simplify both sides and we move variables to one side and constants to one side by doing the inverse of operations, which sometimes will involve square roots, cube roots, squaring, cubing, and so on. And then finally, we solve for our variable applying BIDMAS. So BIDMAS means brackets, indices, division, multiplication, addition, subtraction. Remember, the mathematical order in which we solve our equation is of utmost importance to ensure the accuracy for our question. Amazing. So then we go into some examples. Here we are asked to solve the following equation showing all are working. The first, very simple, but involves a square. So we're told that x squared is equal to 64. So first of all, we recognize that in the question, the operation given is a square. We need to do the inverse of that operation, which is square root. So again, I'll rewrite my question. I've got x squared is equal to 64. So therefore, to solve this, I must do the square root of both sides of my equation. So I need to do the square root of x squared and also the square root of 64. So whenever I find the square root of a square, I actually remove that square. So the square root of x squared is just x on its own, and the square root of 64 is 8. But importantly, this could be positive 8 or negative 8. Very important note here, every square root has two values, a positive and a negative. Let's qualify this. Minus 8 multiplied by minus 8, two negatives will give a positive. So this will give positive 64. Similarly, positive 8 times positive 8 is also 64. Now, for some questions may give you this simple question here, but will say find the values of this equation. And you will wonder, how does the question say values when I only know that square root of 64 is 8? And that's because the other solution is a negative. Two negatives multiplied to give me a positive, hence every square root has two answers, a positive and negative, and I want you to get into the rhythm. I remember one student lost 1 mark on an exam because they did not remember to put the negative 8 or whatever it was as a value as well. So make sure that you remember this. So the next question is x squared add 5 is equal to 30. So again, looking at what we've got in the question and what we need to do. So here we've got a plus 5, we need to do a minus 5, and we also have a square, which means we're going to need to do a square root. So the first thing I need to do is to subtract 5 from both sides. So on this side, I've got x squared left, and that's equal to 30 minus 5, which is 25. So I've done my inverse of a plus 5. Now I need to do the square root of both sides. So the square root of x squared and the square root of 25. Square root of x squared is x, since x times x gives me x squared. Square root of 25 is either positive or negative 5. Remember, negative 5 times negative 5 is positive 25, and positive 5 times itself also positive 25. Absolutely brilliant. Now we're going to do an example where we've got a square, but that square also has a coefficient. So in this question, I've got 2y squared is equal to 200. Now I must first of all take care of my coefficient first. I am multiplying by 2, so I need to divide both sides of my equation by 2 first of all before I can do my square root. Very important. So dividing both sides by 2, 2y squared divided by 2 is just y squared, and that's equal to half 200 is 100. Now I've done that, what I need to do is to do the square root of both sides. So the square root of y squared and the square root of 100, square root of y squared is just y, and the square root of 100 is plus or minus 10, since 10 times 10 is 100 and negative times negative also positive 100. Beautiful. Now we go to another question which will involve 3 steps this time. So I've got 3x squared minus 4, and that's equal to 8. Step 1, I need to take care of my minus 4 first by doing the inverse, which is adding 4 to both sides. So therefore, minus 4 add 4 cancels the 0, so this is going to be 3x squared equal to 8 add 4 is 12. Beautiful. Next step, I need to take care of my coefficient. So I need to divide both sides by 3. So 3x squared divided by 3 is just x squared, and that's equal to 12 divided by 3, which is 4. Now I need to do the square root of both sides. So square root of x squared and the square root of 4. Square root of x squared is x, and the square root of positive 4 is plus or minus 2. 2 negatives again, multiply to give me positive 4 as well. Absolutely brilliant. We can see here, once we know how to solve any equation at all, it is just applying the principles to whatever questions we're given, just that we need to make sure we know what are the inverse of each operation. Awesome. So now we're doing the reverse of what we just did. We work on our squares, now we're going to work on our square roots. So we're asked to solve the following equation, showing all our working. First one, we are given the square root of x is equal to 5. So we are doing square root in the question. We then need to do the opposite, which is squaring. So we need to square both sides. I'm just going to put in the bracket what I'm squaring. So just like we said, a square root removes a square. Similarly, a square removes a square root. So when we square a square root, we will get the variable on its own. So the square of the square root of x is just equal to x, and the square of 5 is 25, because 5 squared actually means 5 times by 5. Common mistake students make here is to do 5 times 2. They would have gotten 10. That's incorrect. 5 squared means 5 times 5, which is 25. We can now check our answer. The square root of 25 is equal to positive 5, or it could also have been negative 5, but this question gave us the positive version. This is how we check, guys, and make sure that our answer is correct. Beautiful. Now we go to the next question, which is on cube root. So I've got the cube root of x is equal to negative 3. So in the question, I'm given cube root. In my solution, I need to do the cube. So remember, a cube removes a cube root. So we're going to go ahead and cube both sides. So this is going to simplify to give us x. So the cube root of x raised to the power of 3 will cancel that out, leaving us with just x. Now, important to note here, cubing minus 3 means we're doing minus 3 times minus 3 times minus 3. Now, negative 3 times negative 3 is positive 9, but positive 9 times negative 3 brings us back to negative, which is negative 27. So once we are multiplying negative numbers and we've got an odd number of negatives, the answer will be negative. So we've got 1, 2, 3 negatives. 3 is an odd number, so therefore the answer will be negative. If I'm multiplying even number of negatives together, as in the case of -3 and -3, that would have been 2 negatives. 2 negatives will give me a positive. 4 negatives will give me a positive because 4 is an even number. Very important to note that. Now we move along to our next question, where we're doing the square root of x plus 4 is equal to 7. Rewriting x add 3, sorry, the square root of x add 3 is equal to 7. So in the question, we are doing square root. To solve it, we need to do a opposite, which is squaring. So we need to square both sides of the equation. So we're doing, remember, a square removes a square root. This is how we're now going to get access to x. So this will just be x add 3 equal to 7 squared is 7 times by 7, which is 49. Last step is to subtract 3 from both sides. So we've got x left here. 49 take away 3 is equal to 46. So x is equal to 46. And again, rough quick check, we can see if I put 46 in my root, then 46 plus 3 is 49. So the square root of 49 is indeed 7. Prove your answer, particularly you've got time in your exam or in your class test or in your classwork. Spend the time to prove your answer. Very important there. So similarly, we need to do root of 2x equal to 6. Opposite of square rooting again is squaring both sides. So square removes the square root. So now we've just got 2x equal to 6 squared is equal to 6 times by 6, which gives me 36. Final step is to divide both sides by 2. So x on this side is equal to 36 divided by 2. Half 36 is 18. So x is equal to 18. Beautiful. You can see the clear logical thoughts there. Always talk yourself through, what am I given? What's the opposite of that? And then you navigate your way through application of the steps we have looked at before. Absolutely brilliant. So now we've done squares, we've done square roots. Now we're going to look a little bit more as to where we now need to apply the concept to both sides and then collecting like terms like we did when we had unknowns on both sides. So question context changes, but principles remain the same. So again, I've got in this question asked to solve for x. I've got the square roots of 3x minus 1 is equal to 5 this time. So what I need to do, opposite of square rooting is squaring. So I'm squaring both sides. So square removes a square root, gets me to 3x minus 1 equal to 5 squared means 5 times 5, which gives me 25. Now what I need to do, 2 steps. So I need to first of all reverse my minus 1 here with a positive 1. This cancels out to 0, leaving me with 3x on the left hand side. 25 add 1 is 26. Now I need to divide by the coefficient of x, which is 3. So dividing by 3, 3x divided by 3 is just x. You could just look at it, cancelling it out. That's equal to 26 thirds. Now, because I recognize that if I divide this, I will get a recurring decimal, a good exam principle is just to leave it as a fraction here, just to avoid that, unless the question asks you to give your answer correct to a particular degree of accuracy, which could mean 2 decimal places, 1 decimal places, and so on. Beautiful. Now let's go over to this question where we got 2 square roots on either side and also 2 unknowns. So now it's just about combining skills. We know how to collect like terms when we've got 2 unknowns. We know how to deal with our square root. So this is just a combination of both skills. Beautiful. So root x add 1 is equal to root 2x minus 3. So we know that in order to get access to x on both sides, we need to do the opposite of square rooting, which is squaring. So we're going to square both sides. There we go. Now we have x plus 1 and 2x minus 3. Beautiful. So now it's about collecting like terms and simplifying. Remember, always leave your larger coefficient where it is. So in this part, I'm going to move x to this side and minus 3 to the left hand side. So I've got 1 here. My minus 3 is now plus 3. And that's equal to 2x. My positive x will now be a minus x again, inverse of that operation. So I've got 3 plus 1 is 4. 2x take away x is 1x, which in algebra we just say x. Therefore, x is just simply equal to 4. And again, we can substitute and see if it is our answer is correct. Now, if you look here, if I put 4 here for x, this will just be root 4 plus 5, which is 1, which is equal to 5. And on the other side, if I do 2 times by 4, which is 8, 8 take away 3 is also 5, so that's root 5. We've got root 5 on both sides. This tells me I am correct. Absolutely brilliant. And by the way, root 5 is a surd. And if you don't know what that is, go ahead and watch that video there on surds, introduction to surds. You need to know what a surd is. Beautiful. So let's go to our next question. This time we move away from our square roots and squares to our cube roots and cubes. Beautiful. So in this question, we are solving 2x cubed equal to 54. And then the next question is x cubed plus 1 equal 28. Guys, principle remain the same. I cannot stress that enough at all. So 2x cubed is equal to 54. Step 1. Take care of my coefficient by doing division by 2 on both sides. Absolutely brilliant. So 2x cubed divided by 2, 2 cancels out here, which is equal to x cubed, and that's equal to half 54 is equal to 27. Now I need to do the opposite of cubing, which is cube root. So I will write that the cube root of x cubed is equal to the cube root of 27. Remember, the cube root of x cubed is just x. What this means is that x times x times x 3 times gets me to x cubed. So the cube root of x cubed is just x on its own. So the cube root of 27, what number multiplied by itself 3 times gets me to 27? And the answer is 3. So 3 times 3 is 9, and 9 times another 3 gets me 27. So the cube root of 27 is equal to 3. Absolutely fantastic. And again, you could also prove that by substituting it back into the original question, and the answer should be 54. So now we go to another question where we got x cubed add 1 this time is equal to 28. This means we've got to take care of our constant first before focused on the cube root. So we've got a plus 1 in the question. We know that we need to do subtract 1. So minus 1 on both sides here gets me to x cubed, since positive and negative 1 is equal to 0. Then 28 minus 1 is 27. Beautiful. I've got a cube here. I need to now do the cube root to get x on its own. So the cube root of x cubed is equal to the cube root of 27. This simplifies the same. So x is also equal to 3. If you notice here, this one I haven't put a plus or a minus, because if I have minus 3, this will now translate to minus 27, which is not what I was given. So only an an even root as a square, fourth root, and so on, will have two possible solutions. Please do not get that confused. So the cube root has one solution because three negatives multiplied together will give a negative. So that will make your answer incorrect. Very important there. Okay, guys, so we go to another question where we're given the cube root this time instead of the cubes. So we're given that the cube root of x minus 5 is equal to -2. So again, rewriting my question, cube root x minus 5 is equal to -2. So we know that the opposite of cube root is cube. So I need to cube both sides to remove that. So cubing both sides, I will now have x minus 5. Remember, our cube removes the cube root, so we only have x minus 5. Now we are also cubing -2. Again, -2 times -2 times -2. So -2 times -2 is +4. But that +4 is also being multiplied by another negative. So the answer is going to be -8. Remember, 3 is an odd number. 3 negatives together multiplied will give me a negative. Absolutely brilliant. Now I've got x minus 5 equal to -8. I now need to do the opposite of -5 on both sides to keep that balance. So I've got +5, +5. So adding 5 to both sides, positive and negative cancels to 0, leaving me with x. -8 add 5 is equal to -3. So again, look, I owe 8, I pay 5, I will still owe 3, minus being the sign of owing. And you can also substitute that back in again, as I always said, just to prove your answer. Beautiful. So now, guys, we go to the next question. So I'll rewrite that again. So I've got cube root of 3x plus 6, and all of that is equal to 3. So cube removes the cube root, so we're cubing both sides. So I've got 3x plus 6 equal to 3 cube is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So now we need to do this in 2 steps. So first of all, I need to subtract 6 from both sides. So I'm left here with 3x equal to 27. Take away 6 is 21. Last step, I need to divide by the coefficient here, which is 3. So 3x divided by 3 is equal to x, and 21 divided by 3 is equal to 7. Absolutely brilliant. So guys, we are moving along to our key takeaways. Absolutely fantastic. So at the beginning, we talked about an exponent. We say an exponent is just another way of saying power or index, and the plural of index is indices. Now, these are just the small numbers seen above the base number or the variable. So we looked at an example where we talked about, for example, 8 to the power 3, and we said that the 3 was considered the exponent. Beautiful. We also talked about what a root is, and we said a root of a number is that value that when multiplied by itself a certain number of times, it produces the original number. We cited, for example, that the square root of 25 is 5, since 5 times 5 makes 25. But we also talked about the fact that a square root or even roots will have two values, one positive and one negative. And this does not apply to any root that's an odd number. For example, cube root, which is a 3, will not apply. Beautiful. Now guys, we have now come to the end of this lesson, which was done in 4 parts. Make sure that you have engaged with all 4 parts. You've done all the independent practice and solidify all the skills that we have explored. Make sure that you like the video, you share it. If you haven't subscribed yet, make sure that you do, and also interact with our content over on TikTok. Until the next upload, guys, thank you so much for watching.